Is a younger, slimmer, taller, smarter male climate scientist. Dr. Alex Hall is the author with his colleagues of the mid-century warming study that I'm here to give you highlights of. He couldn't be here today, so he sent me with his slides. If you don't like the slides, they're not mine. So I will go through them as well as I can. I'd like to move to the first one if I could. So that's a major disclaimer, right? So Alex is a member of the International Panel on Climate Change, and he shows here the, oh, this is interesting. He shows here, somebody changed my slides. Okay, let's move on. So he shows right here the emissions scenarios that are going to be put out and forecast by the next climate panel. And you can see that they vary greatly based on the red being business as usual and the orange, green, and blue being various levels of trying to mitigate and slow climate change. So we can go to the next one. I'm hoping that the next one is there. Please, next one. Okay, sorry about that. Let's see. Okay. So here it shows what the forecast is going to be in terms of warming based on those different scenarios. So if you go back to the other slide, you saw the red line is the business as usual line, and the blue line, what happened here? Okay, don't want to go back. Want to go forward. Okay, so the blue line is the doing as much as we can to stop climate change. The bottom line of this globally is that no matter what we do in terms of warming, we're going to be warmer than we have been in the past. But you can't say much about Los Angeles or the San Gabriel Valley based on what's happening in terms of the international climate models. So here, this is not working. Somebody split these out for me. Okay, here we go. So here it shows, for instance, topography of California. We just got a great zoom in from Kurt on what really the topography looks like. And on the left-hand side, it shows what the global climate models assume the topography is. There's no Sierras, there's no valley, there's very little, very different kind of topography. And on the right-hand side, it shows the topography that was generated by Dr. Hall with his high-resolution climate models at 18, 6, and 2 kilometers. 2 kilometers is like neighborhood level. So he was able to, for topography, pretty much mirror what we're doing here. And that's how he was able to do what's called downscaling. So he's taking the global climate models and he's trying to adapt them to the real place where we live. So he looked at that for topography, for ocean currents, for winds, for weather fronts, for vegetation, for land cover, and other. There's many terabytes of data in these models. And so what he's trying to do then is look at how these global changes are going to affect us in the real places where we live. So here's an example of what we think we have for the Los Angeles region. You can see the LA County on the maps. And this, again, is not my slide, but I'll try to walk you through it. The top is the fall, what weather is going to look like in the fall, and then the winter, and then on the bottom, the spring, and then the summer. So if you look at the scale at the bottom, you'll see that there's everything from yellow to dark, dark orange, and that means that there's going to be between a 2 and a 5 degree increase in surface air temperatures, minus the current, including the current baselines in the future. And we're talking about not tomorrow, we're talking about 2050. So basically what the bottom line of this research shows is that we're going to add heat, and we're going to both add it on average to the average daily temperature, and we're going to, most importantly, we're going to add the number of super hot days. So mountains and the deserts, we're going to add the most extreme hot days, maybe 5 to 6 times as many hot days as we have right now. The valleys, including the San Gabriel and San Fernando Valley, will add the second most, 3 to 4 times as many as we have now, with the coastal basin the least number of hotter days, but still 2 to 3 times the degrees annually. I wouldn't try to draw any water conclusions from that, but I bet a bunch of you in the audience could. This morning, we talked about how water demand has been a lot lower because it's been a cool summer. And so we're talking about a lot of issues with these numbers of extreme hot days and average increases on hot days. Certainly will have a lot to do with water demand. So I think I've summarized fairly much what his research to date shows. It shows an average of 4.6 degrees. Okay, again, somebody really fixed this for me. So for the business as usual scenario, the most likely mid-century warming is about 4.6 degrees, averaged over the regional land areas with 95% confidence that somewhere it's going to be somewhere between 1.7 and 7.5 degrees Fahrenheit by 2050. Coastal, the high elevations, again, I talked to you the difference between the high elevations and the coastal locations. And then under the mitigation emissions scenario, or the one where we try to do something about climate change, this is the majority of the warming that's seen under just business as usual still increases significantly. So therefore, what he concludes and we conclude is that whatever we do at this point about climate change, we're going to have warming. And that if we have warming, the best thing we can do is figure out how we're going to adapt to living in a warmer place. So over the next year, Alex will be producing studies similar to the one presented here, quantifying changes in precipitation and snowfall, more directly applicable to the water agencies here. Santa Ana wind strength and frequency and duration. You know, we know that we had the station fire. It ended up sedimenting up our dams. We know that when you have a fire, there's less water absorption. So the fire cycles are going to be important. Stream flow, soil moisture and evaporation, and low clouds, or otherwise, are we going to have June gloom, and how is that going to affect water use? I encourage you to get more information about the project. Now that went away. Let's see if I can get that. Further information is available, and you see the website here. It's http://c-change.la/. And the actual report that's being published now is on the website, so you can get the detailed information about it. You would have otherwise gotten an hour lecture here. And then I also wanted to note that this report was done with funding that the county and the city obtained, the county and city of Los Angeles obtained from the stimulus funding. And it was done because the city and the county and the other members of what's called the Los Angeles Regional Collaborative for Climate Change and Sustainability were organized to figure out how we're going to adapt to climate change. And they wanted not to do it, their work. They didn't want to make investments and decisions based on the more general climate information. They wanted to know how it was going to affect this area now. So they're busy already at work looking at the impacts of these warmer days on public health. We certainly hope the Institute of the Environment and Sustainability is the sort of administration, not the members, but the administration for LARC, and we're hoping to provide more support to them as they develop these implementation strategies. I would really encourage water agencies and cities here and private businesses to become engaged with LARC, because I think that it's going to take all of us working together to learn how to live in a warmer Los Angeles. Thank you.